So in this question, first, we're given some information about the population of department chair ages in the US. We are told that they are normally distributed and that the population mean is 55 years and the population standard deviation is 5.3 years. So this is the underlying distribution of X mean, mu, and this is the underlying distribution of X standard deviation, sigma. Next, we're asked if 24 department chairs are selected at random, then 18% of the time their mean ages will be greater than how many years. So this is a sample that has an N of 24, and we're asked a question about the sample mean. So it's always useful to sketch out the distribution that you're dealing with and what part of the distribution you're looking for. So this is the sampling distribution of X bar. That's because we're asked a question about a sample mean. We want to find the age cutoff so that 18% of samples of size 24 will have a mean greater than that value. So we're looking for the upper 0.18 of the distribution to be greater than what value? This is our X bar distribution, which we know is distributed normally with a mean of mu, the population mean of 55, and a standard deviation of sigma over the square root of n. So this is how we're going to define our distribution in Desmos. So now I have a Desmos window open and I'm going to use normal dist, which I can either type or I can pull up from the distribution template. And I need to put in my parameters. So the mean of the distribution that we need, which is the sampling distribution, again, it's not the underlying X distribution, is 55, and the standard deviation is the standard error of the sampling distribution, 5.3 over the square root of 24. We are looking for, again, the cutoff value of the top 18% of the distribution. So by sketching my region over here, it helps me visualize what I need to select in the cumulative probability calculator. I want a right-sided area, and I'm not computing the area. I know the area that I want. I need to compute the bound. It's the bound of that area that I don't know. So I'm going to select right and compute bounds, and then I'm going to put in the area that I want to the right of the boundary that I'm looking for, and I get 55.99. We are asked to round to one decimal place, so the cutoff value that we need here is X bar equals 56 years. That's the cutoff for the top 18% of the distribution.